Hello, my beautiful AP CSA students. Welcome to another lesson in Unit 4, Data Collections. We are now on Lesson 4, which is going to be Array Traversals. And in this lesson, we are going to talk about one-dimensional arrays and how we use a loop to look at all of the elements in an array. We'll also start to modify the elements in an array using a loop. We'll talk about methods and arrays and how those work together, and then we'll finish the lesson talking about the for each loop. So it's going to be a good lesson today. We're going to learn a lot more things about one-dimensional arrays, which we first introduced in Lesson 3. So grab your notes, get settled in, and let's go through this content together. So traversing an array. Now, when we talk about traversing an array, the word traversal, it means that we are going to look at every element in the array or look at the contents of the array. And to do that, we are going to use a for loop to access each item in the array. The for loop is going to be the easiest way to do it because the for loop has an indexed header. Well, we know it has the header, and it has an index in the header, and that built-in index in the for loop will allow us to use that variable to represent the index in our array. So a for loop is just the natural way that we go to traverse an array. You can use a while loop. There's ways to use a while loop. We'll learn about the for each loop, but the normal for loop is really the go-to way because of that index in the header. Usually it's called I, but remember that your variables can be called whatever you want, okay? Inside the for loop, we use that variable I that represents the index of each of our arrays to either access or modify the contents of the array. So what that looks like is we might have an array creation here. So int called myr and equals, and then we're just not shown that creation. But let's say our instructions, we just want to traverse the array to display the contents, okay? Now, normally we can't just do a system.out. Like if we want to know what numbers are in this array, we can't just do this, right? Other programming languages, you can just say, okay, print and then put the name of the array. We cannot do that in our Java language because this is a reference variable. It points to the data. It does not hold the data itself. And because it points to data, when you do this line, all that is going to print off is a memory location. Okay. Again, in other languages, that's different if you've learned other languages, but in Java, we don't do that. So instead, we have to use a loop to display the contents. So all of our loop headers are going to look so similar. And this is kind of the general template for traversing an array, starting at the first index and going through all of the indexes that are loaded into the array. Now, I say starting at the first index, but obviously we start at index 0. So that's why we have int I equals 0. And then here we go up to, but not including myArray.length. Again, we don't know how long my array is in this example. The creation is not shown. And when we want to write loops, and eventually in the next lesson, when we want to write algorithms, we always want to make our code general so that it can apply to any situation, whether my array has 10 numbers or it has 1,000 numbers. We want our code to be able to work with whatever. So this is the kind of template we use. I less than myArray.length. It says go up to, but not including the length of the array. So remember, if my array has 10 numbers, the length of it is 10, but the last index is a 9. Okay, so we want it to access index 9 and not index 10 because there is no index 10. So that's what this is going to allow us to do, is go up to, but not including the entire length of the array. And then we want to go up by 1. So we start at index 0 and we go up by 1 every single time to make sure we're hitting each element of our array. So that's what our header is going to do. I also want to say, just for style purposes too, a lot of the times I don't put a space between the for and the parenthesis, kind of like how I do with all the loops and with my code for my selection statements, all of that. But a lot of the times you might see a space here, which is totally fine. That's just a style preference, okay? So just remember that there's going to be some style differences there. And then here's all we have to put in the body of our loop is a system.out.println my array I. Okay, so remember, this is going to be the code that allows us to access a specific element. And each time I is going to be changing. So the first time through I is 0. So it's going to display the element at index 0. I increases to 1. Next time through, it's going to display the element at index 1. Then we go back up. I becomes 2. Okay, and we keep going until I reaches a point where it's no longer a valid index. So this is all the code. This allows us to display the contents. Now this is a print line statement. So this would allow us to display the contents one at a time on each different line. Okay. So there's going to be different things you can do to make it so that you can have the output you want. Okay. If you want it all in one line, maybe with a space, we'll see an example of that. You can kind of control the output and how that looks for you. Let's look at another example. This time we're traversing an array for array creation. So I've created my array called my R again equals new int 50. Okay, so this is going to create an array of 50 numbers that's going to hold 50 integers. Now remember, when we have this whole line of creation, what's put into the array right off the bat is the default value for it. For an int, which is 0. So right now you have an array of 50 zeros. But let's say you want to put all multiples of 2 into the array starting at 0. So you want to put in 0, and then put in 2, and then 4, and then 6, and then 8. Okay? So on and so forth for all of those 50. Okay? And you don't want to write 50 lines of code to do that. So we're going to use a loop. Now, one of the things that you have to start doing, especially for a situation like this, is think about how the contents of the array might or might not relate to the indexes. In this case, we do have a relationship between them. So this would be index 0. Oh, oops, sorry. I clicked off there. This would be index 0, index 1, index 2, index 3. So maybe that's something we can use and use to populate our array here. So first I'm going to start off with my loop header. Again, this is kind of the general way we move through an array normally. We start at index 0. We go up to, not including the last index, plus 1. Okay, so a nice way to say that. We go up to the length, but not including the length as an index. Right. So if our length is 50 here, there's not a 50th index, but I want to go up to, but not including that. Right. So here's what I can do. All right, I can start off using that relationship of my index to what I want to put in. I can say, okay, if I have index 0, 1, 2, 3, 4, and I want to put in 0, 2, 4, 6, 8. Notice how all of those, if you multiply the index by 2, okay, and you keep going for, up to the length of the array, you're going to get the contents that you want. So you're going to use that and say, okay, take I times 2, whatever the value of I times 2 is, and put it in the value at index I. Put that value into index I. All right. And that's how that might look. When we get more into algorithms, we talk more about algorithms in the next lesson. Today, we're just kind of practicing traversing and reading these loops and going through them. When we get more into algorithms, finding patterns like this, like I just pointed out, is going to be so helpful to writing those algorithms when you can find a pattern. If you can't find a pattern, remember, you can always just create a new variable to do it, okay? There was a few different ways. You didn't have to use the index I. You could have used a brand new variable that increased by 2 each time the loop was called, okay? There's going to be varying ways of doing this and writing the algorithm, but this was one way that my brain thought of, so. All right, now I have example number 1 here. I have 6 examples we're gonna go through. So you're gonna wanna be able to both trace arrays to figure out what's happening in this array traversals, but you're also gonna be able to start writing code involving array traversals. So we're gonna go through 6 examples here to help us do that. So this question, it just wants to know what's printed. So we're going to go through and we are going to trace through this to see what is printed. So I have int values equals 2, 7, 11, 4, 13, 8. And then what is happening? Now, one of the things I like to do is to put English language to the code. So when I look at this header, what I see is this right here. Traverse through each element in the array. That's all I see. So that means whatever I'm doing in the body, I'm going to just be doing to each element in the array one at a time. Okay. And that allows me to trace through this code in a much easier fashion so that I don't necessarily have to make, a table and keep track of I. You definitely could, especially as you're still learning these. If you need to make a formal trace table, by all means do it. But if you can start putting words like this to the code, it's going to help keep it clear in your head what you're doing with this array. Okay, so this tells me I'm going to traverse through each element in the array. Then this next if statement tells me if that element at the current value, if I mod it by 2 and it's equal to 0, what does that say? That's asking, is the element even, right? When you divide it by 2, if your remainder is 0, what do I want to do? Well, if the element is even, I want to print it off. Okay, I'm going to do a print statement, which means I'm going to print off the value and then I'm going to add a space after it so that all of them get printed on one line. Okay, so I'm going to traverse through each element in the array. If the element is even, I'm going to print it off. Okay. So by putting English language to that code that I'm tracing, now I can just go through the array and ask those questions. So I'm going to start at 2. It's even. I'm going to print it off. 7 is not even. 11 is not even. 4 is even. I'm going to print that off. 13 is not even. And then 8, that's even. So I'm going to print that off. Okay. And now I have 2, 4, 8. That's what gets printed to the screen. So as you practice these, as you get good at them, that is what we are going to look at, and that is how we are going to move through these problems when they're asked what is printed. Here's another example. If you want to see what is different about this one versus the other one, it looks very much the same, except the header, it's going to still be the same. Traverse through each element in the array, but look at this. Now it says if the index is even, because I'm using just I. In number 1, I was using values I, which is looking at the actual element. Now I'm just looking to see if the index is even. Okay. If the index is even, print off the element. Okay. You're going to have to be very careful about those differences when you're reading these questions. I and then values of I. This is checking if the index is even. If the index is even, print off the element. Okay. What has even indexes? Well, this has an index of 0, 1, 2, 3, 4, 5, right? So this is an even index, this is an even index, and then 4, I keep getting off here, and then 4 is also an even index, okay? So those are my even indexes, and then I print off the elements. So 2, 11, and 13 are what is actually going to get printed to the screen. Good. All right. More practice. What is printed? All right. Now we're really mixing things up here. Okay. I have a array of string elements here. Farm animals. Okay. And then now look at this loop header. Look at what's happening here. This is a different kind of loop header. And what this does is going to traverse through each element in the array backwards, right? So now we start at farm.length minus 1, okay? Because remember, farm.length, I have 6 farm animals, and the length is 6. But 6 is not a valid index. It goes from 0 to 5 as my valid indices. So if I want to go through backwards, the last index is going to be 5. Okay? So how do I get 5? I take farm.length, which is 6, and I subtract 1. And then I'm going to decrease my index 1 by 1 each time until I get down to 0. Okay, so while I is greater than or equal to 0, starting at 5, then it's going to be 4, 3, 2, 1, and 0. I want to include 0 because that's the index. What do I want to do? Okay, so this is going to traverse through each element in the array backwards. Okay, then what do I do? Okay, if the word's second letter is equal to O. So look at, we got a few strings here. So farm I. So that says take the element and check. Okay, it's a string, so I take that element and I look at substring 1, 2. What is 1, 2 going to give me? That's going to give me the second letter. Okay, the second letter. And if that second letter is equal to O, what am I going to do? Okay, so this is either going to be true or false because it's the dot equals here. So if the second letter is equal to O, what am I going to do? I'm going to print the word. Okay, print the word, followed by a space. Okay, so now I've looked through that traversal. I have it in my head. Here's what's going on. Okay, I've made sense of what's happening, and now I can go to farm and I can actually apply it. Okay, so each element backwards. So I'm going to look at sheep first. Is the second letter O? Nope. So I'm not going to print that. Then I go to chicken. Is the second letter O? Nope. I'm not going to print that. I go to goat. Is the second letter O? Yes. Goat's going to be the first word printed. Pig. Is the second letter O? Nope. Cow. Is the second letter O? Yep. So cow's going to get printed next. And then my last one, horse. Is the second letter O? Yep. So I'm going to print goat, cow, and horse. Okay, in that order because I worked backwards. I traversed backwards. Goat, cow, horse. Okay, each separated by a space here. Okay, look good? We're going to have to practice a lot with these just to get comfortable with them. We're just learning about, traversing through arrays. So that's okay if you look at this and you're like, I had no idea that was the wording for it. Okay, that's all right. That wording is going to come with a lot of practice. Okay? And we're going to be using these a lot with arrays, and then eventually array lists, and then eventually two-dimensional arrays. So you're going to be just fine through practice. Okay. All right, let's write a little bit. Finish the code so that the sum of the elements in the array is printed. If you do want to try this on your own, feel free to pause. Let's go through what the answer would be, how we should think about this. So int ARR, short for array, that's pretty typical language on the AP CSA exam. They just call it ARR for array. So the array elements are not shown. So again, I have to make sure I write code that's general, that can work for any array that I have, whether it's 5 elements or 1,000 elements. So I have my array, and then I have a variable called sum that's going to be 0. So I want to add up all the elements in the array. So what do I have to do? Think of the English first. Think of the pseudocode. I know I want to traverse through the array. I have to look at every element. And then what do I want to do? I want to take that element and I want to add it to sum. So I'm going to look at the first element. I want to take that, add it to sum. Take the second element, add it to sum. Third element, add it to sum. Okay. Those are my 2 steps. Traverse through the array, number 1. Let me write the code that's going to traverse through the array. When thinking about algorithms, you got to think about how you should go through the array. Do I go through forwards, backwards? Do I skip anything? In this case, I want to look at every element, and it doesn't matter if I go forwards or backwards. So I'm just going to go forwards. Okay. Start at 0, go up to, not including the length, 1 at a time. And then in the body, I just do the one thing. I add the element to sum. Okay? So I take the element that I have, ARR, I, and I'm going to add it to what is already in sum. Okay? And that's it. That's the code. And then I print off at the end, the sum is whatever the sum is. Okay? Yeah. Not too scary. Not too scary. We're getting it. 2 more examples here. What is the value of count after the code is executed? Another great one here. Okay, let's see what's happening. There's a couple things that are going to be new in this situation. Notice how my array traversal header in my for loop has changed a little bit. I have int count equals 0, int nums equals, and then I have an array of numbers. And then in my header here, I have it still starting at 0. And now I go I less than nums.length minus 1. Now, what does that say? That says traverse through each element in the array except the last one, okay? Except the last one. So starting at 0, going through up to, but not including the last one. And the reason why is you'll see in a second, okay? Why wouldn't I want to include 10? Why do I want to go up to nums.length minus 1? Let me show you. It's because of what's happening here in the body of the loop, okay? This one, what is this question? It says if nums I plus 1 is greater than nums I, okay? Okay, what does that mean? Okay, think about what that means. So this is our current element, is just nums I. Okay, we call anything with just a plain I our current element as we traverse through. So our current element, and then what's I plus 1? Well, that's going to be the element next in the list. Okay, if I is our current element, I plus 1 is going to be what's next in the list. Right? It's going to be the element next. So this is saying if the element next in the list, that's what this represents. If the element next in the list is larger than the current element, what are you going to do? You're going to add 1 to count. Okay? You're going to add 1 to count. That's what that means. So when I start off here, my current element is 4. Okay? So starting off, I is 0. The current element is 4. This says, so this is right here, nums I is going to be 4. Okay? Since I is 0. Okay. And then 0 plus 1 is 1. So this is going to be the next element at index 1, which is 8. Okay. Is 8 greater than 4? Yes. So we're going to add 1 to count. Okay. So count is currently 1 after 1 traversal. Okay. Now that pattern, we're going to trace through each time. Next up, is 5 bigger than 8? Nope. Is 11 bigger than 5? Yes, so count has 1 added to it. Is 12 bigger than 11? Yes, so we're going to have 1 added to it. Is 10 bigger than 12? Nope, so count doesn't get 1 added to it. Now look where we're at right now, okay? This is our current element, that's the circle, okay? Now I is going to increase. So I is going to become, this is the current element at 0, 1, 2, 3, 4. This is current element 4. I is going to become 5. And then is I still less than nums length dot 6? No, or excuse me, nums length dot minus 1. Nums length is 6. 6 minus 1 is 5. 5 less than 5 is false. So the loop ends. Now, why did the loop end there? That's because if we were to continue this and if 10 became our current element, and then if I tried to go 1 index above where that 10 is located, I would get an index out of bounds error because there is no next element, okay? So if I had it go all the way up to here as my current element, and then I tried to run this code right here saying, okay, look at the next element, it would have thrown a compiler error because there is no, or excuse me, a runtime error, index out of bounds, because there is no boundary that goes up that high. So that's why we had to traverse through each element in the array except the last one. Okay. Except the last one. So we're going to see that a lot when we get into our array algorithms in the next lesson. We have to be careful of the boundaries of our array and that we're not going out of boundaries accidentally. Okay. So that's a little taste of it. We'll keep practicing that. Okay. All right. 6. This is going to be, I believe, the last example before we start talking about methods and arrays. Okay. What are the contents of the array after the code has been executed? This is a good one if you want to try it on your own. This is kind of a tricky, almost a puzzle type of question here. Would this be on the AP exam? I don't know. I just thought it was fun and I like puzzles. So it's a good spot if you want to pause it, try it, and then press play when you're ready to see me trace through the answer. Okay. So mystery. We're going to trace through. Mystery has 5 zeros. It's created with 5 zeros. That's what that line means. This one says mystery 0 is going to be 8. Right? So after this line of code goes, the index 0 is going to have an 8 in it. Mystery 1, this one has 2 plus mystery 0. Remember that this is accessing the element, so this is going to be an 8. 2 plus 8 is 10, so 10 is going to go into the first index. Next up, mystery 0, again, is going to be 8. What is 8 mod 3? That's going to be 2. left over, and mystery 2 is going to equal 2, which is why our array now has 8, 10, and 2. Ooh, this is a good one. Okay, this is a good one here. Mystery 0 is 8. Okay, 8 is going to go into what spot here? Okay, what is this spot? Well, mystery 2. Okay, what is mystery 2? We have a mystery inside a mystery. Mystery 2 is currently 2. Okay, this currently has a value of 2. What's 2 plus 1? 3. All right, the best math. And then now that 3 refers to the index. Isn't that cool? So mystery 3 is going to be equal to 8. You see what I did there? Very cool, very cool. Inside, puzzle inside a puzzle. We love it. Oh, and now we have a traversal. What does this say? Traverse through each element backwards. Okay, so this has starting at I equals mystery.length minus 1. So this starts at the very last index. Go up to, but not including index 0, okay? Subtracting 1 each time. So I'm going to start here and go down 1 at a time, but not including index 0. Okay, why might I not include index 0? Well, that's because of what I have right here. Okay, mystery I minus 1. Okay, traverse through each element backwards, and then this says, take the element before it, multiply it by 3, and then store it in the current array element. Okay, so what's going to happen? So we start off with 0. Okay, take the element. What came before it? Okay, what's coming before? 8 comes before it. So take 8 times 3, which is 24, and then store it in that current element. Okay, so 24 gets stored in the current element. Perfect. Now I'm going to move through. My current element is 8. What comes before 8? Okay, what comes before 8 is 2. 2 times 3 is 6. So 6 gets stored in place of 8. Then I traverse, I move down to the next one, element 2, at index 2, 2 as well. What comes before it? 10. 10 times 3 is 30. So 30 gets put in there. Okay, next current element is number 10. What comes before that? Number 8. 8 times 3 is 24, so 24 gets put there. Okay, and again, this traverse through each element backwards, but not including 0. Okay, because if I were to go down to I use 0, I get I minus 1, which is negative 1, and I don't have mystery of negative 1. I can't have negative indexes. I would get an index out of bounds. So I got to stop there. So what does that mean goes in place here? Well, that just never changed. That element never got touched. So that 8 stayed the same. Okay. All right. So that is going to be my last, that's my answer. This is the contents of the array after all of this code has been executed. Okay. All right. Now let's talk about passing arrays. So in the last unit, we discussed how primitive types, including strings, are actually passed by value, meaning you pass a copy of the argument value to the method. So any changes that you make to that variable in the method are not preserved. So if you pass it a value, if you pass a method a value, the original value that came from where you passed it, if it was a variable, if you passed a variable, that is not affected at all. But objects and arrays as well, because they're a special type of object, they do get affected. Okay, reference types pass the reference of the object. So just like we've talked about objects and how when we pass objects, if you change an object in this method, it changes the object overall. That's going to be the same thing that happens with arrays because we pass references of arrays. So any changes made to the array are going to be preserved, meaning they are going to be affected back in the original method. Okay, and this is easy to see, hopefully with an example that I have here. Okay, so this is going to be example 1. I have 2 examples of this. Okay, 2 examples of this. So example 1, this is my class. I have my main method here, and then I have my static method down here. So I'm not working with objects. I am working with just arrays just to kind of show you an example of this. I'm going to have stats I'm going to have 5 integer values. I'm going to call on manipulate stats. So that means I'm going to pass an array reference to the manipulate. Notice how in manipulate, it's expecting to receive an integer array. It's going to do something with the integer array, but it's not going to return anything. Okay? It doesn't return anything. It just does something with the array. And then after this code is run, I come back up here. And then I'm going to display the contents of stat. Okay? So recognize that this code, hey, that displays the contents of stats. Okay. So let's do a formal trace of this. So stats, here's what it looks like. Here's how I like drawing it off in memory. Kind of the same as objects, right? Stats is our reference. It's pointing to the contents of the array. I'm going to make a call to manipulate. And when I come down here, ARR, okay, it expects an array of integer values. ARR becomes a second reference for that same array. So now that array of 30, 40, 50, 60, 70, it has 2 references pointing to it, stats and ARR. Okay. So now down here, this code says go through each element of ARR, okay, because I use ARR.length. Go through each array element. While the element itself, so this is the element, while the element is not divisible by 3, not evenly divisible by 3, increase it by 1. Okay. So let's do that. Okay. 30. 30 is our first element. Okay. Again, I'm working with ARR. So ARR is pointing to this array. Okay. So 30 is our first element. Is 30 divisible by 3? Yes, evenly divisible. Okay. It equals 0 when you mod 3. So I don't do anything to that. I move on to the next one. Is 40 mod 3 not equal to 0? Yes, that is true. So I'm going to add 1 to it. Is 41 mod 3 not equal to 0? That's false. Okay. No, that's true. 41 mod 3 is not equal to 0. So I increase it to 42. Is 42 mod 3 not equal to 0? False, because 42 is evenly divisible by 3. So I move on to the next one. Okay. 50 mod 3 is not equal to 0, so I increase it to 1. 51 mod 3 is evenly divisible by 3. So I move on to the next element. 60 mod 3 is 0. Okay, so I move on to the next element. Is 70 evenly divisible by 3? No. So I add 1. Is 71 evenly divisible by 3? No. So I add 1 to it. Is 72 evenly divisible by 3? Yes. And I'm done. Okay. I am done. I come back up here. Now what happened here? Where did ARR go? Remember that ARR, because it was declared inside this method, it is a local variable just to this method. So once this method gets done running, it goes away. Okay. The reference goes away. But notice how the array didn't go away. Okay. Because that array still has a reference pointing to it. Okay. That array still had stats pointing to it. So the array itself, along with the changes that were made, did not go away. Okay. Stats is still pointing to that. So when I come back up here after my method is done and I go through each array element and print off the contents, I'm going to get 30, 42, 51, 60, 72. Okay. I am not going to get this because it was manipulated down here in my method. Okay. So that's what we mean when we say that the changes are preserved, meaning that the changes made under this reference are preserved. They stick with that array so that when you go here and print off stats, you see those changes get printed off. Okay. Methods can also return arrays. So that was a void method that we saw an example of, changes being preserved. Let's look at the code that returns arrays. So what is printed when the following code is run? Here's our second example. Again, just kind of glancing through. Here's our main method. Here is our second method. Okay. In the main method, I have int numbers. Okay, so I'm going to draw this out. Numbers is going to point to an array of 5 integer values. And then here I have code where I call on my method called positives. I'm going to pass it an array called numbers. And then whatever the array that's returned is going to be put into other array. It's going to expect to return an array of Boolean values. So let's go down to positives here, okay? Positives into ARR, okay? So since numbers was passed here, that means that numbers and ARR are going to point to the same array. And then look, I'm expected to return a Boolean of arrays, an array of Boolean values, okay? I'm going to return an array of Boolean values. So what's going to happen here? In this code, I have Boolean new array equals new Boolean r.length. So what this is going to do, what is r.length? Well, r.length, there's 5, okay? So the length of r is 5. So it says create a new array of Boolean values called new array with a length of 5. Okay? And all of them get the default value for a Boolean, which is false. Okay? Now this code says traverse through ARR. Okay? If the element is positive in ARR, what are we going to do? We're going to change the Boolean in new array at the same index to true. Okay? Same index as true. So go through the code, put some English to it, okay? We're going to go through one by one in ARR, and if a value is positive, the same index in new array is going to be changed to true, okay? So is 10 positive? Nope. 15 is positive, 20 is not positive, 25 is positive, 30 is not positive. So at index 1 and index 3, index 1 and index 3, we're going to see both of those values get changed to true. Okay? That is what positives did. Okay? And now positives is going to return new ARR. Okay? When it returns that, it returns it back up to the method call, and now it gets put in other ARR. Okay? So it gets passed back up, and now the reference is called other ARR. New ARR went away because the method has ended. After the method returned it and after it got captured, then the reference for new ARR it's gone, right? But this array was still captured by other ARR. Okay. And then same thing with this ARR here. It went away. It was garbage collected. The method was done. I just threw my pen. It came back though. Woo. Garbage collect everything, including my pen. No, so that went away as well. Woo. So now this is going to go through numbers.length, okay, one at a time, and it's going to print off with numbers plus a space plus other ARR. Okay. They both have the same length. So you're going to see numbers get printed off, followed by the Boolean at that same position. So -10 false, 15 true, etc., etc. Okay. So that would be an example of returning arrays. There's some situations where you might want to return an array, some situations where you want to modify an array. It really just depends on what algorithm you're using and what the purpose of your program is. Sometimes it doesn't matter. You can do either, but you want to keep both of these methods straight. Get it? Methods straight. Whether you want to modify an original array or whether you want to return a whole new array. The last thing we're going to talk about in these notes, I know it's long, so thank you for bearing with me, is the for each loop. I want to talk about the for each loop. It's a new type of loop. It's called the for each loop, or also the enhanced for loop. And this loop uses a modified syntax to traverse through arrays. It also works on array lists. Okay, but it uses a modified syntax. Here's what the syntax looks like. It's simplified. So for type var in array, and then we use a statement using var. So when reading this code, we say for each var in array, do this with var. Okay? Now, var represents the current element in the array. So the current element as you traverse, starting at the front and going all the way to the end. When the loop repeats, the variable r will reference the next element in the array. Okay? So if I have an array of numbers, the first time through, var will be 10. The next time through the loop, var will be 20. Next time through the loop, it'll be 30, etc., etc. So var changes, var represents the element, not the index. Like a typical for loop, I would represent the index. For an enhanced for loop, the variable, we usually don't call it I to not be confusing, but the variable name will reference the element. Okay? Here's an example. Let's just say I want to print the contents using an enhanced for loop. Here on the left in the table is how I would do it using a regular for loop. Okay? I start at index I equals 0 up to not including the length, increase by 1 each time, print it off, plus this, right? This is how I would do it. If I want to use an enhanced for loop, I still have the array. Now my syntax says int n in R. Okay, so this says for each element n in the array ARR, print off that element plus a space. Okay. So notice how with the enhanced for loop, we've gotten rid of indexes. Okay. We don't deal with indexes anymore in an enhanced for loop. In an enhanced for loop, we are strictly dealing with the elements. So the first time through, n is going to be 2. The next time through, n is 5. Then n is 3, then n is 7, then n is 9. Okay? An enhanced for loop always starts at the very first element of the array and goes through the end of the array. Okay? So the for loop says do something a certain number of times, whereas the for each loop says do this with every element in the list. Okay? In the list that you have, do this with every element. So practice, write a for each loop to accomplish the following tasks. In an array of integers called numList, print off the odd elements. So if you want to try this, let's see what the answer is after you paused it, tried it, and then come back. Okay. So in numList, if I want to print off the odd elements, I write a loop header that first gets what the element is. So int num in numList. So I'm going to get the num, the element, in numList. Okay, remember, num changes each time in the list, but let's say it's the first element. I want to check to see if it's odd, because if it is odd, I want to print it off. So I'm going to write code to check if it's odd. Num mod 2 equals 1. That means it's odd, and then I want to print it off. Okay. Again, I don't use indexes at all in a for each loop. Okay. No indexes. Num here represents the element itself, the element value, not the index. If I wanted in an array of string called words, let's say I wanted to print off the first letter of each word. So here now, since words is going to have strings, now I have to change this variable. It's going to be a string because words is an array of strings. Okay? So value. So value is going to represent the word. Each word is going to change each time as I traverse through this array. I want to check, and I actually don't want to check anything. I just want to print off the first letter of each word. So I'm going to take value, and I'm going to find the first letter by using dot substring 0, 1. And that's going to get me my first letter and print it off. Okay. Look good? Okay. A few last things about for each loops here. Any for each loop can be written as a for loop, but the opposite is not true. Okay? The opposite is not true. There are limitations when it comes to using a for each loop in an array. For example, you cannot modify contents of an array in a for each loop. Okay? Let me show you what I mean. Okay? The code below is correct and it will run. However, it's not going to run like you think it will, okay? And I have students who write this and they think it's good and it runs, it compiles fine, but it doesn't do what they expect it to do. And I'll explain why. I mean, it's written there. Let's trace through this here. So int ARR, let's say it's this. I want to go through each number in an array. I want to add 1 to that number and then print it off. Okay. So the first time through, num is 2, and then num is 3. So 3 gets printed. Second iteration, num is 5, add 1 to it, 6 gets printed. So on and so forth, right? So 2, add 1, print, add 1, print, add 1, print, add 1, print, add 1, print. So that's what gets printed to the console with that code segment. All right. I'm going to print a new line. And now when I go through again, int num in RRR, okay, and now I just print off num, what gets printed? This content. Okay, because what happens in here does not modify the original array. Okay, num is a local variable to the loop it is created in. It gets assigned the value of the element in the list. It does not represent the element in the list. Okay, right? Remember ARR, this is the reference. It's pointing to 25379. Okay. The only way to change the array contents is to access it with an index. When we have num gets assigned the value of the element at 0 index, but it doesn't actually point to the location, meaning any changes made to num inside the loop are not preserved because num is a local variable. Okay. So many students, when they write this code right here, they expect those changes to stay, and those changes do not stay. Okay. You can manipulate num inside, but it does not change the original loop at all. So please be careful of that. A for each loop does not modify array contents. Okay. If you wanted to modify the contents of an array, you need to use a regular for loop. So here's what would happen to the same code using a regular for loop. So if I used indexes and then I actually took the element and I added 1 to it, okay, so I take 2, I add 1, 5, 3, okay, I get print off all the same. If I go back through, those changes were preserved because I accessed the array element and then I modified it. Okay, sound good? All right. Oh yeah. Oh man. And that's the end of our lesson. So in general, with the for each loop, if you need to modify the array or if you need to use the index for anything, don't use a for each loop. Okay. For each loops work the best when you are just trying to access and view the contents. If you need to modify or if you need to know the index for anything, don't use a for each loop. Always use a for loop. And that's kind of wrapping up the for each loop there. And in fact, that actually wraps up our whole lesson because now we have reached the end of our notes. Finally, thank you guys so much for following along. I know this was a long one, so I appreciate you guys sticking with me. If you've liked this video, please hit the like button and subscribe to my YouTube channel for more great AP CSA content. And until then, I will see you in the next video where we are going to start talking about one-dimensional array algorithms. Thank you guys so much for being here. I will see you then.